Hello everyone. Today we'll be talking about segment relationships in circles. And we're going to be learning about 3 different theorems today. So first, just for some vocabulary, when 2 chords intersect in the interior of a circle, each chord is divided into 2 segments that are called the segments of the chord. And we have segments of chords theorem. And this theorem tells us that if 2 chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So let's look at this diagram to see what exactly this is telling us. So I see that I have 2 chords here. I have chord A, B, and I have chord C, D. And I see they both intersect at my point E. And what this theorem tells us is that the chord segments of my first chord, so A, B, my 2 segments would be EA times EB, is going to equal the lengths of the segments of the other chord. And so now I'm going to go from EC times ED. So let's put this theorem into use in these 2 problems. So for number 1, I want to find the length of ML and JK. So I want to find the length of both of my chords. And for this one, I'm going to need to first find the value of X so that I can plug that in to find the length of both of those segments. So I need to use my theorem here. And again, that's telling me that the chord segments, the product of them is going to equal for both chords. So here I see I have chords M, L, and KJ, and they intersect at N. And so my theorem tells me that for my first chord, ML, I'm going to have NM times NL, and that's going to equal the segments of my second chord, KJ. So NK times NJ. Well, NM is equal to X plus 2. NL is equal to X plus 1. NK is equal to X. And NJ is equal to X plus 4. So now I need to go ahead and distribute. For this first, on the left-hand side, I'm going to do a double distribution. So I have X times X to get X squared. X times 1 to get X. 2 times X to get 2X. And then 2 times 1 to get 2. And that is going to equal to X times X to get X squared. And X times 4 to get 4X. And then I can go ahead and simplify the left-hand side by combining my X and 2X. I get X squared plus 3X plus 2 is equal to X squared plus 4X. Now I need to go ahead and simplify. I see there's an X squared on both sides, so I can go ahead and cancel both of those out by subtracting X squared from both sides. So then I have 3X plus 2 is equal to 4X. And then I'll just subtract 3X from both sides. So I get that 2 is equal to X. So I found my value of X, however, that's not what the problem was asking for. It was asking me to find the length of ML and JK. Well, ML is just going to equal to both of these segments added together, so X plus 2 plus X plus 1. However, I know that my value of X is 2. So ML is just going to equal to 2 plus 2 plus 2 plus 1. So ML is equal to 2 plus 2 is 4, 6, 7. And then for JK, that one is equal to X plus 4. So it's going to be 2 plus 2 plus 4. And so I get that JK is equal to 8. Okay, let's try another problem just like that. So here I want to find the value of x. I see that I have two chords intersecting inside the circle. So I know I'm going to be using this segments of chords theorem because they're intersecting inside the circle. And so that tells us that the product of the lengths of the segments of the chord is equal to the product of the lengths of the segments of the other chord. So for this one, I'm going to have 3 times x is equal to 6 times 4. Well, 6 times 4 is 24. And then dividing both sides by 3, I get that x is equal to 8.